Hello guys, welcome back. So here's a simple example of for drawing a freeboard diagram. Alright, so the scenario is that there are two boxes, or there are two blocks, block A and block B, and there's a pulley. Alright, and there's a rope attaching block A, and connecting block A and block B, and the rope goes over this pulley in this particular manner. So this is a rope, and this rope is undeformable. It doesn't deform, right? So that's the condition that we assume for statics always. In statics, these things are, that is in this playlist, the things are always undeformed. We do not consider the deformation of the states or of the blocks or any object over here. We just consider the blocks as block or anything as undeformed, and then calculate the forces. Right. So the rope here is undeformed. Okay. So that is, it doesn't stretch. Okay. So that's how it is, and it's in the influence of gravity. Right. So draw the freeboard diagrams of block A, block B, and the pulley C. Right. So let's start with the block A. Okay. So let's draw block A first. So this is block A. So okay, so first of all, it's under the influence of gravity, so the gravity must act. So let's just draw the first force of gravity. Let me use yeah. So this is a force of gravity over here. All right. So the force of gravity, Fg. The first force. Okay. Now the second force, of course, it's under the influence of gravity. Still, it's not moving in the downward direction because of the normal force and the perpendicular direction to the surface. So the normal force, as you can remember, it's always perpendicular. Okay. So it's perpendicular to this surface, that is perpendicular to this surface, so it's gonna go in this direction. So the normal force is gonna go in this direction. Normal force and A. Okay. Now there is a rope attached in this direction, so the rope must be pulling it in this directions. See, there is a very important thing. A rope can only pull; it doesn't push, right? So if, let's say, if there's a block and there is a rope attached, so the rope is gonna, the direction of the force is always gonna be in the, like it's always gonna be pulling the block, right? The rope always can pull it, the rope cannot push. So let's say there is a rope attached to the block, so we cannot draw the force by the rope in this direction because the rope cannot push it in and push the block in the opposite direction. The rope can only pull. Okay, so that's the most important thing. Many of, I mean, this seems like common sense, but many of the people actually go wrong over here. So that's the thing. So there's a rope, and the rope is gonna push it in this direction. So the direction of the force is horizontal towards the right. So this is, let's denote the force exerted by the rope as Fr. Okay. So three forces till now, and there's no frictional force mentioned. I didn't mention any frictional force in this problem, so there's not gonna be any fourth force on this particular block. So this is for three forces: one gravity, the second normal force, and the third the force exerted by the rope. So I cannot see any other force over here. So that's the freeboard diagram of block A. Okay. Now we'll move to pulleys, or let's just do block B first. Okay. So let's draw block B first. So let me draw block B. So this is block B. Alright. So block B. Okay. Now for block B, the rope is gonna pull it in this direction. Again, the rope can only pull; it cannot push. So it's gonna be pulling the force, pulling the block. So the direction is gonna be in this, not this. No, this is wrong because the rope cannot push. Okay, so the rope the force exerted by the rope is gonna be in this direction, and it's just denoted as Fr. Okay. Now a very important thing. This Fr and this Fr, is it gonna be same or is it gonna be different? Well, we mentioned in the start of the problem that the rope is undeformed, right? And it's the same rope that connects to block A, that goes over the pulley C, and then connects to block B, right? So it's the same force. So if the rope is undeformed, and if it's the same rope throughout, then at each and every point of the rope, the force in the rope will have to be same. If it is different, then the rope will have to be deformed. Well, that's not the case over here, right? So the rope is undeformed, so at each and every point in the rope, the force has to be same. So no matter how many objects the rope is attached to, at each object, to each object, the force exerted by the rope is gonna be the same. Okay, so this Fr and this Fr are exactly the same. They have to be the same actually. Okay, because the rope is undeformed. Okay, so let's move. So this is Fr, this is block B, and now the gravitational force acting in the downwards direction. So this is the gravitational force, and so let's we denoted this gravitational force of A as Fg. Let's just call it Fga to avoid confusion. So this is Fga, so this is gonna be Fgp. Alright, so you can just write like this as well if you want. Okay, Fga and Fgb. So because these two gravitational forces are of course different unless the mass of the two objects are the same. Alright.